We're monitoring a dangerous situation developing in Washington state. At least 6 rivers are hitting major flood stage this morning. That is the most severe level of flooding, and the water is still rising.
Washington state, located between the restless Pacific Ocean and the towering Cascade Mountains, is a land shaped by fire, water, and time. Its lush forests, mist-shrouded peaks, and rain-soaked coastlines have long given the illusion of stability, but beneath this serene surface, something extraordinary is unfolding, something that is shaking the foundations of what geologists believe to be true. Deep below the Pacific Northwest, where the bones of the Earth grind in darkness, a hidden transformation is underway. For the first time in the scientific record, researchers have observed signs that a subduction zone beneath this region may be actively breaking apart. The very crust of our planet appears to be fracturing miles underfoot. Shockwaves from this buried violence ripple upward, sending silent warnings through forests, rivers, and cities that sit unaware above it all. Far offshore, seismic instruments probing the abyss now detect fractures where the planet once seemed solid and unbroken. For centuries, humans saw only the surface and trusted its apparent calm, but far below, order gives way to chaos. Massive slabs of rock collide, grind, buckle, and now, disturbingly, fracture in ways scientists never fully anticipated. Here, danger is not legend. The same colossal forces that feed volcanoes like Rainier, shake the ground beneath Seattle, and bend the crust of the Pacific Northwest are beginning to behave in new, less predictable ways. And in geology, change never comes gently. What does this discovery mean for Washington, for the Pacific Northwest, and for the millions who call this land home? If the crust beneath is truly splitting apart, what new hazards are being born in the darkness below? Today, we follow every tremor, every rupture, and every whisper rising from beneath Washington state, because the secrets buried here are rewriting what scientists thought was possible. Are you ready to see just how fragile our world really is? Chapter 1. Cascadia's secret fault awakens. Imagine a beast slumbering in darkness for centuries. Then suddenly it stirs, stretching for more than 600 miles from Northern California to British Columbia. The Cascadia subduction zone was long regarded as a silent threat, a fault line, quiet and mysterious, its true power hidden from modern memory. But quiet does not mean harmless. Beneath the tranquil woods and churning coastlines, forces great enough to move continents have been building pressure. And now, scientific instruments have revealed what no one could see. Cascadia is not only active, but shifting in a way scientists had never recorded. What makes this particular fault line so unusual, so dangerous, and so unpredictable? The answer lies in its anatomy. Subduction zones are enormous geological engines. In Cascadia, the Juan de Fuca Plate, the final relic of the once vast Farallon Plate, sinks beneath North America, steadily dragging down fresh seafloor and building up stress invisible at the surface. When that stress is abruptly released, it can unleash earthquakes strong enough to level cities and send tsunamis streaming toward distant shores. But for the first time, geologists have caught Cascadia doing more than straining. They see it breaking, with new fractures forming within the subducting plate itself. This is not just the usual grinding and slipping at a locked boundary. This is the skeleton of our continent bending and cracking, with consequences reaching far beyond the Pacific Northwest. How do scientists track these silent shifts? In recent years, advances in seismic tomography and ocean bottom seismometers have given scientists an unprecedented window into the hidden machinery beneath Cascadia. Ultra-sensitive instruments detect faint tremors, revealing a web of tiny quakes and fractures that, pieced together, signal the beginning of a massive transformation. Changes in gravity, subtle tilting of the land, the slow warping of forests, and the emergence of underwater vents all give clues that things are changing. Pulling these signals together, geologists know that for the first time, Cascadia's system is transitioning into a more complex and unpredictable phase. Chapter 2. Earth's crust is splitting here. Crust splitting might sound like fiction, but off Washington's coast, it's becoming geological reality. Seismic data show that a section of the Earth's crust is actively breaking apart beneath the ocean. Imagine the bedrock of a continent starting to peel away, layer by layer, deep under the surf. These aren't superficial cracks from shaking ground, but deep wounds running through the planet's outer shell. So, what's happening beneath the Pacific Northwest? Why is this region the site of such dramatic geologic change? The answer is in the relentless motion of plate tectonics. The small Juan de Fuca Plate, made from ocean crust, is being forced beneath North America in a slow, steady collision. But instead of gliding smoothly or simply locking tight, this ancient boundary is developing new breaks internally, an unprecedented event for a subduction zone caught as it happens. The crust is splitting apart from within, making this corner of North America one of the most geologically dynamic places on the planet. To appreciate the scale, consider that the crust here is up to 20 miles thick, built of countless layers formed over millions of years. Normally, when plates collide, most of the strain is absorbed or released at their contact zone, but new imaging has shown kilometer-long fissures venting fluids and gases, deep cracks still widening and shifting, and swarms of microquakes echoing through the dark. These are not just curiosities, they are powerful geological features that can reorganize the planet's surface, creating new patterns of ridges, basins, and even future island arcs. As the splitting continues, geologists believe that small plates or microplates may emerge here, reshaping the ocean floor on geologic timescales. Chapter 3. The jigsaw beneath our feet. Is Washington State itself a geological jigsaw made from many ancient pieces forced together? The region's geology is not the story of a single continent, but of dozens of fragments, microcontinents, slivers of seafloor, slices of volcanic terrain, fused together by eons of collision and upheaval. What does this patchwork mean for earthquakes and volcanoes today? Every seam between ancient fragments is a place where future stresses can focus and faults can reactivate. When the crust splits anew, these old weaknesses can serve as pathways for earthquakes or even volcanic activity. Instead of a single solid block, Washington is a patchwork of buried vulnerabilities, each a potential trigger for disaster. Much of the land underfoot traveled thousands of miles. Chunks of what is now eastern Washington were once isolated volcanic islands, carried gradually eastward until they collided with North America. Many forested hills and mountain slopes are, quite literally, scraps of lost worlds, each with its own set of ancient boundaries and hidden faults. As new tremors rise up from below, these fractures can be reawakened, sometimes shaking only a small area, sometimes reorganizing the map of risk in ways that challenge prediction. Chapter 4. Tectonics rewrite the rules. What if the rules of plate tectonics, the decades-old foundation of geology, need to be rewritten? The theory explained how continents drift, mountains grow, and faults slip. But in the Pacific Northwest, scientists are witnessing the limitations of those rules. Plates can sometimes break apart internally, not just at their edges. Why is this breaking happening now and not before? Over millions of years, as plates move and heat rises from below, stresses build within the plates as well as at their boundaries. When rocks inside the plate become too weak or too hot to hold together, they fracture, somewhere no one expected. This means hazards can develop far from any traditional boundary, threatening areas thought to be safe. Traditional models focused on dangers at well-mapped plate margins, but discoveries under the Pacific Northwest show that breakage is also possible anywhere plates have internal weaknesses or extra heat from the mantle. Satellite thermal imaging has spotted zones of abnormal heat seeping through, suggesting some spots are more prone to internal rupture. As these stress-filled patches accumulate strain over decades, they can fail suddenly, catching even the best prepared communities off guard. Chapter 5. The forgotten warnings of megaquakes. Can long silences in the geologic record be misleading? The last time the Cascadia fault fully unleashed its potential was in the year 1700, long before written records in the region. Clues came later, from standing dead forests killed by saltwater, and from Japanese officials' records of a mysterious tsunami. Scientists analyzed these signs to reconstruct the magnitude 9 quake, capable of shifting landscapes and inundating coastlines in minutes. How do today's discoveries change that picture? As evidence mounts for crust splitting from within, the classic rules of rupture grow more complex. Earthquakes may no longer run neatly along mapped lines, but could jump, twist, or multiply across newly formed cracks. If internal splits help trigger a future Cascadia event, it might mean less predictability, not necessarily greater size, but more complexity and risk. Modern researchers look for ancient tsunami deposits and sudden shifts in tree rings to understand past disasters. These records warn that civilization can be upended in an instant. The rise of multi-segment earthquakes, where internal splits combine with surface faults, raises new concerns. Though not proven, it is plausible that a break deep within could connect with shallow faults, releasing more energy or complicating the rupture sequence, thus challenging all current seismic hazard planning. Chapter 6. When subduction zones break. Why is it so significant that scientists have caught a subduction zone in the act of breaking? Subduction zones have been shaping continents, mountain ranges, and seafloors for billions of years, recycling the crust in a process fundamental to the planet. Witnessing an active break gives researchers invaluable clues into the creation of new seismic hazards, such as intraplate earthquakes, unfamiliar rupture patterns, or even new types of tsunamis. This subduction breakdown could also shift the balance that shapes entire landscapes. If parts of the subduction zone behave differently now, if breaks shift how stress is distributed, mountain ranges could lift or subside faster, valleys could deepen or transform, and the flow of groundwater might even change, affecting rivers and lakes. Observing Cascadia's transition is like watching the planet's inner engine encounter a previously unknown failure, a rare opportunity to learn, but also a warning for everyone living above. Chapter 7. Volcanoes erupting through solid rock. How do volcanoes push through rock that's been hardened for millions of years? In Washington, volcanoes like Mount St. Helens and Mount Rainier stand as evidence of the powerful forces beneath. Traditionally, major eruptions occur along known weak zones near subduction boundaries, but as the crust splits, magma may find new routes to the surface. Could this open new eruption risks? Possibly. Deep fractures create new pathways for magma to rise and for heat to reach the upper crust. In recent years, both ground swelling and minor increases in volcanic gases have been detected near some of the region's volcanoes. As new channels open, it's possible, though not yet confirmed, that future volcanic activity could become more widespread or appear in unexpected places. Chapter 8. Strange earthquakes rewrite the map. What if earthquakes appear where none have before? For years, seismologists mapped the region's quakes to known faults, but now a new breed of tremor is reported, sometimes deep under the ocean, sometimes beneath forests far from mapped boundaries. What causes these odd events in forbidden zones? Scientists suspect that internal breaking of the subducting plate is activating new fault pathways. Each unexpected quake not only redefines the risk map, but underscores how incomplete our understanding remains. One example, episodic tremor and slip events under the Olympic Peninsula, a series of faint, slow-moving shakes not considered typical earthquakes, but deeply significant. These have revealed themselves along new cracks forming at depth. Sometimes hundreds of such tremors occur in waves, hinting at ongoing changes in the internal structure of the plate beneath. While these events are not direct threats like major quakes, they point to a shifting system in which future quakes could strike in previously quiet regions. Chapter 9. Microplates, birth of hidden dangers. could unseen fragments amplify disaster? As the crust splits, entire chunks, microplates, could break free, multiplying the number of small boundaries underneath. These fragments move, turn, and sometimes grind past each other, creating a tangled web of hidden danger. How could this affect Washington's future? With stress now building not just at major boundaries, but at seams between microplates, the potential sources for earthquakes expand. Scientists must now look for these invisible lines to better predict where future ruptures might trigger landslides, minor quakes, or other fast-moving hazards. Microplates typically move only millimeters per year, detected by careful GPS or satellite mapping. Yet their boundaries can become sites of small but destructive quakes or slow movements that impact river courses or even contribute to sudden landslides. It is not impossible that many moderate disasters over time, rather than a single giant event, will be the hidden legacy of these shifting plates. Chapter 10. Tsunami threats multiply. Tsunamis are coastal nightmares. But what happens as the sources of these waves multiply? When the crust fractures internally, earthquakes can strike in new places, changing the math for tsunami risk along Washington's coast. Every new break off the coast is capable of displacing huge amounts of water, even if the source is far from conventional monitoring lines. Should microplates slip, or should the subduction zone unzip in an unexpected way, the resulting waves could approach the coast with less warning. Current tsunami alert systems are designed around major, shallow quakes on known faults, but internal ruptures might produce signals that are harder to detect or interpret in time. Historical accounts and geological evidence show the Northwest has suffered surprise inundations before. As scientists deploy more sensors on the seafloor, they hope to catch these events sooner. But for now, communities must be prepared for the unexpected as source points for tsunamis expand. Chapter 11. Stress migration, a chain reaction awaits. Is stress beneath the Northwest capable of migrating like falling dominoes? As the crust breaks, the forces once trapped offshore could shift inland. What was once primarily a hazard for coastal fishing towns could someday move toward mountain ranges, cities, and farmlands miles from the sea. How could this play out? When one part of the system releases its pressure through a quake or a split, it can set off movement along connected faults, including those that have lain dormant for centuries. Scientists have observed that moderate offshore earthquakes can sometimes be followed by movement on inland faults days or weeks later, hinting at a connected system of stress transfer. Even volcanic systems are monitored for subtle unrest following distant tremors, in case a chain reaction of events is possible, although a full, multi-stage disaster chain remains a subject for ongoing research.
Chapter 12. The Ring of Fire tightens. The Pacific Northwest sits on the edge of the infamous Ring of Fire, a horseshoe of geological instability that produces most of the world's volcanoes and earthquakes. But what happens as new fractures form in Cascadia's stretch of this chain? With every new break, the network becomes more intricate. The region might see increases in inland volcanic activity, new faults, and seismicity in places previously thought safe. And while it is unlikely that local events directly cause disasters on the far side of the Pacific, stress changes in one place can subtly shift balances elsewhere over long timescales. The fate of this region is interwoven with that of other Ring of Fire communities, from Alaska to Japan, from Chile to the Philippines. Chapter 13. Lessons from the ancient past. Has the Earth warned us before? Consider the Farallon Plate, a colossal plate that once dominated the Pacific Basin, now mostly devoured and transformed into smaller fragments like the Juan de Fuca buried beneath the Northwest. Its disappearance was a saga of destruction, megaquakes, erupting volcanic chains, and relentless changes shaping the coast. What can geology's history teach us today? No plate is permanent, and every split or break, such as those being documented now in Cascadia, is part of the planet's cycle of renewal and destruction. The region's patchwork composition and record of ancient upheaval show that new landforms and risks are always being born, and that the recent findings are simply the latest in a long series of fundamental changes. Chapter 14. Redefining catastrophe. What does catastrophe look like when the ground beneath us changes the rules? Earthquakes and eruptions can no longer be defined solely by the boundaries mapped by previous generations. Internal fractures, once thought rare, are now recognized as a force to be reckoned with. As the science evolves, cities and towns must prepare for new threats from unexpected directions, depths, and mechanisms. For the millions living in Cascadia's shadow, the timetable for the next disaster is uncertain. New rupture pathways may connect previously isolated faults, increasing the chance of linked catastrophic events. For disaster planners, this requires a shift, imagining not just one big one, but the real possibility of sequential or compound disasters. An earthquake in an unmapped location, a tsunami triggered in a newly discovered seam, and the chain of landslides or volcanic activity following on its heels. Emergency planners and scientists are working closely with coastal and inland communities, native groups, and regional governments to share findings, update hazard maps, and prepare for a new era of risk defined by growing uncertainty. What once seemed rare is now part of a future that demands resilience and constant vigilance. Chapter 15. The hidden future beneath Washington. The secrets beneath Washington are becoming visible at last, revealed in the breaking crust, new microplates, unusual earthquakes, and seismic awakenings. Each discovery pushes the limits of our understanding, showing that even what once seemed solid can change in an instant. For those living near Cascadia, this is more than just a scientific revolution. It's a call to reimagine what risk, safety, and preparedness mean in a changing world. The question is no longer just when the next disaster will occur, but how our understanding of Earth's restless forces will shape our response and resilience. As the rules are rewritten beneath our feet, Washington is only the beginning. If you crave a deeper dive into the hidden machinery of the planet, from fractures to seismic mysteries, join us. Even as the ground beneath us shifts, knowledge and preparation remain the best tools we have.